Dear student, in this video, I am going to share with you the next part of the conformations of polysubstituted cyclohexanes. So in previous videos, we already discussed these two isomers. Now in this video, we are talking about menthol, that is 2-isopropyl 5-methyl cyclohexanols. And these are the remaining molecules that we had to discuss under this heading. So menthol, this is 2-isopropyl 5-methyl cyclohexanol. This is the structure of menthol. The second position, isopropyl group. The first position, hydroxy group. Fifth position is the methyl group. And as this due to these three substituents, C1, C2, and C5, these are the asymmetric centers. Hence, as there are three asymmetric centers, it exists in 4 DL pairs. So this is the first one, menthol. In menthol, all the structures or the substituents are equatorial. In that, isopropyl group is going in a downward direction, while hydroxy group and methyl group going in the upper direction. This is denoted by equatorial conformer. So this is the first structure, menthol. Now, which on treatment with aluminum isopropoxide, it get converted into a neomenthol. This neomenthol is dextrorotatory. So this positive and negative sign indicate this negative sign means this is the levorotatory structure, and the positive is this one is the dextrorotatory structure. When it is treated with aluminum triisopropoxide, then the orientation of this hydroxy group changes to axial hydroxy group, and the name of this is the neomenthol, while this conformer is denoted as AEE conformer. The third one is plus isomenthol. The structure of plus isomenthol, here the stereochemistry of methyl group changes to axial with respect to the menthol. In menthol, all the groups are equatorial, while in isomenthol, the methyl group is axial. While in neomenthol, the hydroxy group is axial as compared to menthol. So this is again, if it is treated with the same aluminum triisopropoxide, the stereochemistry of hydroxy group changes to axial, and this is denoted as AEA conformer, and the name of this is neoisomenthol. So neo term is used for the orientation of the hydroxy group. In neo term, the orientation of hydroxy group is axial, while the iso term is used for the orientation of the methyl group. Iso means if the methyl group is axial, then it is termed as isomenthol. While in menthol, the negative menthol, all the groups are equatorial. So this is the first structure, that is negative menthol. This is the mirror image of the negative menthol, which is denoted by plus menthol. These are the mirror images of each other. And as you see, there is absence of symmetry. Therefore, it exists in a DL pair. This is the most stable conformer. The reason behind is all the substituents are equatorial. And hence, due to absence of symmetry, this compound is optically active. So this one is the how it looks in ball and stick model. These are the structure, how it appears in ball and stick model. Now this is the next one, that is the neomenthol. Neomenthol is the orientation of the hydroxy group changes to axial, and this is the negative neomenthol. That is, this is the mirror image of positive neomenthol. Again, there is absence of symmetry Hence, it is optically active and exists in a DL pair. This is the third molecule, that is isomenthol. This is the first one is the positive isomenthol. The mirror image of this is the negative isomenthol, in which the stereochemistry at C5 changes that as compared to the menthol. And again, due to absence of symmetry, it exists in a DL pair. This is the, again, these are the structures which are shown in ball and stick model. This is the last one, that is the neo-isomenthol, and this is minus neo-isomenthol. This is dextrorotatory neo-isomenthol. Here, neo stands for the orientation of hydroxy group is axial. Iso stand for methyl group is again axial. So it is neo-isomenthol. This is the mirror image of neo-isomenthol. And again, this you can see here, as there are two axial substituent and only one equatorial substituent. So among all, this is highly unstable conformer. And again, there is a presence of there is absence of plane of symmetry or symmetry element, therefore it is optically active. So for this, you go through these books.